This is a supplementary video for our paper, Spatiotemporal Texture Reconstruction for Dynamic Objects using a single RGB-D camera. To reconstruct a spatiotemporal texture, our framework takes RGB-D frames and a template mesh as the input. Then, we first reconstruct a dynamic object by deforming the template mesh to fit each input frame. A direct way to generate a texture volume for the dynamic object is projecting color images onto the deformed meshes using calibrated cameras. However, this approach can cover only the visible regions at each frame. In addition, projected textures may have drifts among different frames due to misalignments caused by camera tracking and calibration errors. To resolve texture drifts on a dynamic mesh, we present an accelerated approach to optimize texture coordinate for the template mesh on all input images. After texture coordinate optimization, we can see that the textures are more consistent among different frames. Consequently, the dynamic mesh has more stable textures on the visible regions in the input frames. Next, in order to fill in visible areas in the texture volume, we formulate an MRF energy using geometric similarity and temporal texture variation. By minimizing the MRF energy, frame labels are assigned to each face that can constitute a high-quality spatiotemporal texture volume. We then fill the spatiotemporal texture volume by copying texture patches from the input images using the frame labels determined for dynamic mesh faces. In addition, color correction using gradient processing is used to resolve rapid color changes on label boundaries. As a result, the dynamic texture volume can cover invisible regions as well as visible regions at every frame. As we have already seen, the naive projection method cannot cover invisible regions and contains texture drifts. In contrast, our framework can reconstruct a plausible time-varying dynamic textured mesh using a spatiotemporal texture volume. Global Texture Atlas uses a static texture for a dynamic object, whereas our method uses a spatiotemporal texture volume. As a result, it is possible to express time-varying appearances of dynamic objects that cannot be expressed using the Global Texture Atlas. This is a comparison for naively projected texture volume, Global Texture Atlas, and our method. Lastly, the following videos show examples of other scenes. Thank you for watching.